Hey, here we are on Ecology Day, back on social quarantine. And the more people I meet, the more I like my dog because he doesn't mess around. He just sits there, takes a nap, comes over, paws me a little bit, hangs out. Really kind of cool. Whereas some of the people I've seen out in the world or even walking in my neighborhood, I'm like, what's going on with these people? Hey, so let's go ahead and get into it. Climate versus weather. We're going to differentiate those two things. Those of you who are paying attention have noticed that I made my whole screen, figured out a way to change this monitor so that you can see the whole thing. So we don't have to do that scrolly up and down. That's fantastic. And if time allows, we'll get into some of the things that influence and differentiate those climate factors. So here's a couple little notey McNote notes for you. If you are a notey McNote note taker, and not all of you are notey McNote note takers, and that's fine. You can do that. Um, but I guess the clincher here is that if you are looking out of the window today, you are seeing weather. And if you are looking at an overview, you're talking about climate. And so those are going to be the averages. And there are individuals in the news, there are individuals in the media, there are individuals in your life who will use those things incorrectly. Um, Sometimes, as scientists, it just kind of looks like it's semantics. It's just a play off on words, but it does actually mean something to those of us who understand the difference between weather and climate. So as you're looking at those, please use those terms properly. The only way we move forward as an educated society is if somebody starts taking on the education role, and that's going to have to be you guys, so that you can be educated. So anyway, let's move on. So if you're looking at some of the places where we have crazy kinds of weather, crazy is not necessarily the best word, unique types of weather. Sometimes the substrates and the geographical locations alter the way in which those things exist. And before I go any further, much shout out, much props to Mr. Russell. Mr. Russell put together this presentation that I'm creating this video from. So kudos and thank you, Mr. Russell, for taking some time to throw this all together for us. So we do have Tornado Alley. We're kind of in the top zone of Tornado Alley. We're part of it, but we don't see that kind of massive tornadoes like other parts of the Tornado Alley do. But in terms of the way in which where the air masses hit and as they come across our country, and then also the geology and those geographic features, not geology, but the geographic features, mountains, the rivers, the valleys, those are the types of things that are going to influence that. Hurricanes, obviously, looking off of the coastals, and then we know, well, we used to know about lake effect snow, and as that cold Arctic air blows over those Great Lakes, that's going to dump massive amounts, pick up, and then dump a lot of moisture. Those are those fun days. Didn't need any snow days, turns out, because we're having quarantine days instead. So hey, if you're missing out on a snow day from December, January, and February, look what you got here in March, and now we're into April. So don't complain. All right, moving a little slowly, but there you got a couple of those pictures, and you can see. Can you imagine the snow blower that you would need to get through that? That's a full-size tractor. I'm gonna have to check with Mr. Russell, but I think that's the Going to the Sun Road in Upper Montana. It looks like that. Uh, that's how they usually clear it, but I'll have to ask him where he lifted that picture from. And then you can see that's Florida and Cuba off the southern coast of Florida, and the hurricanes that form around in the Atlantic Ocean there. So we have some factors that exist, and there are 7 factors that are listed here. I'm not going to read a slide to you, but I think that if you look at let's look at maybe number 5, the unequal distribution of sun's heat on Earth's surface results in climate zones. We have the polar, the temperate, and the tropical. Polar, temperate, and then right around the middle here, the equator is going to be your tropical, because of the way in which our planet is orbed and the way in which it revolves. We're going to get those different distributions of the sun's heat causing different zones. Any of you who are Gardeners, planters, et cetera, you know that we're in a zone 5. You'll see that on the packet of all your seeds, and it kind of gives you a generalization for the climate that we have in our zone, which would consider in this instance a temperate. So zone 5, temperate, Ohio, there's your growing season. And the rest of it you can pause and see as you need to. So here's a pause face for you. There you go. Okay. We have this thing about the way in which our planet absorbs and then kicks back off heat. This is not going to be new to you. You've heard of greenhouse gases, you've heard of the greenhouse effect. And the reason it's titled as such is because in a greenhouse, a growing greenhouse on the farm or in a plant, the solar panel and the solar rays have enough energy to enter into the greenhouse. They give up a lot of that energy moving through that glass, and then they are unable to escape back out of that glass. And so it traps that heat inside, it traps that energy inside. Well, we're seeing that same type of thing on our planet on a global scale, where the sun's energy can come through our atmosphere, warm up our planet, but the ability of that energy then to escape the atmosphere stops it from doing that. And so we get this bounce back and then it's blocked. So all of that heat, all of that energy is then trapped inside of our atmosphere. Well, we can't block the sun from striking the planet. That's not an option. So the other option is to either figure out a way in which the heat can be dissipated, not absorbed, or allow it to then pass out, so not have as much greenhouse gas, which causes more thickening, bad term, but layering of that atmosphere, which does not allow the energy to dissipate off into space. Heat into space, not a problem. Heat stuck on our atmosphere, kind of a problem. And that's why we're seeing global climate change, and we will discuss this in more detail as time goes on. And then you can see the picture here that we've got in terms of our polar, temperate, tropical, like we had mentioned, and we have some latitudes on there as well. So you can see the less direct and most direct sunlight and the way in which the planet tilts as it on its axis. So I'm going to pause it there. I'm actually going to stop the video there, not even pause it. I'm just going to stop that video, 7.5 minutes. Nice little introduction on weather and climate.